In this video, we're going over the recursive approach of triangle. So given triangle array, return the minimum path sum from top to bottom. For each step, you may move to adjacent number of the row below. More formally, if you are index I on the current row, you may move to either index I or index I plus 1 on the next row. So in our first example, we're given this matrix and we're trying to find the minimum path sum, and the minimum path sum is 2, 3, 5, and 1, which has a sum of 11. Let's go through the thought process. We will be implementing a brute force recursive approach. For each of the cell RC, the current row and column, if we pick the value at the current cell, we have two choices in the next cell or in the next row. The two choices are at R plus 1 and C, and R plus 1 and C plus 1. So if we pick this value, we're only allowed to pick this value at 6 and this value at 5. We will want to pick the choice that will give us the minimum path sum, or that will give us the smaller sum. Now let's go over the pseudocode. So we're going to implement the recursive approach. And then what parameters do we need? We first need our current row, current column, and our input triangle, or input matrix. And then what's the base case? If R is at the last row, we only have one choice left. So we can just return triangle.getR.getC. Then in each of the recursive call, we're going to recursively find the sum 1 of picking the value at R plus 1 and C. So we change R to R plus 1 and C just stays the same. And then we'll recursively find the sum 2 of picking the value at R plus 1 and C plus 1. So R changed to R plus 1 and C turns to C plus 1. And then we want to return the smaller value between the two sums plus the value at the current cell. Now let's go over the time and space complexity. So for the time complexity, we get O of 2 to the R, where R is the number of rows. This is because each recursive call has two choices and a depth of R. So our space complexity is O of R, where R is the number of rows. This is because of the recursive call stack memory. Now let's go over the code. So we're going to implement our recursive approach, keeping track of our current row and column and the input triangle. And then we're trying to find the minimum sum. Now let's go over the base case. If R is at the last row, this means we only have one cell left. Then we can just return the value at the current cell. Now we want to find the sum of picking the value at R plus 1 and C. So we can say sum 1 R plus 1 and C, or we pick the cell at R plus 1 C plus 1, and then we want to return the minimum value between the two sums plus the value at the current cell. This means we have picked the current cell. Initially we start at 0 because we initially start from the top here, so this cell is at 0, 0. Okay, we got our TLE error. So this approach is not efficient enough due to overlapping recursive calls. We can optimize this solution using memorization. In the next video, we'll be going over the memorization approach of triangle. Let me know if you have any questions in the comment section below.